Welcome to DevNetwork's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome all of you to this week's featured webinar presented by Codefresh.io. Codefresh is a regular sponsor of Developer Week events and is a modern CI/CD platform with native Kubernetes integration that helps you build powerful, fast, and simple CI and CD pipelines. Before we get started with speaker introductions, I'd like to remind all of you that we have live chat, which some of you are currently using, telling us where you're logging in from, as well as Q&A, which is available during the session. You can raise your hand in chat or ask questions in the Q&A section of the webinar viewer. We will address your questions at the end of the presentation, so make sure you get some good questions in there. This webinar will be recorded and made available within 24 to 48 hours for additional viewing. Make sure to tell your coworkers to check it out. Okay, so joining us today as your presenter from Codefresh is Dan Garfield. Dan is Codefresh Chief Technology Evangelist, and he is a full-stack engineer, Google developer expert, and a member of the Forbes Technology Council. As a Kubernetes and a CI/CD expert, Dan has built tools for advanced deployment methodologies with Kubernetes, Helm, and Istio. So without further delay, please give your undivided attention to Dan.
Hello. Thanks again for having me and hosting me, DevNetworks. Really appreciate it. Again, feel free to use that Q&A as we go through this, and I'll jump right in. We are going to be talking about CI/CD pipelines for microservices and what best practice that we've gathered both from our users, from our customers, from the community, as well as best practices that we actually practice internally at Codefresh. If you do have any problems with the audio or anything, just throw it in the chat. I am monitoring it, and I'm getting a few notifications, but I think everything's working okay, so I'll just keep going. As mentioned, I am the Chief Technology Evangelist for Codefresh. You can follow me at Today Was Awesome. I'm also a member of the Forbes Technology Council. That badge should say 2020 since we're now in 2020. And I'm also a Google developer expert that's focused on cloud and Kubernetes. So feel free to follow me on Twitter at Today Was Awesome. That's mainly the reason that I do these things. It's not because I want to get back to the community. It's not because I like talking. It's just because I want more Twitter followers than my buddy. We have a bet going. So if you could help me win that, that would be great. It's the only reason I'm doing this stuff. All right. So we're going to do just the briefest of moments on why microservices. And we're not going to really get deep into that. And then we'll get into some lessons learned from an approach that Expedia took a few years ago. And then we'll get into how we do it at Codefresh. So hopefully it should be very interesting. Now, as we head into microservices, I actually want to put on my space helmet here. Not that one, this one. Boom. There we go. Because I want to use an analogy from space. Many of you probably recognize this iconic picture. This is actually a picture of the famous Apollo 13. If you haven't seen the movie, you should totally watch it. But I think it actually has a good example of microservice-based approaches versus monolithic-based approaches. The Apollo 13 was based on, it was basically two ships. You had the lunar module, which is on the left-hand side of your screen, and you had the command module, which is on the right-hand side of your screen. And the command module suffered an explosion, and people couldn't use it. And so they had to go and live inside of the lunar module, which was only designed to hold people for a few hours while they came and went from the moon. So you can think of these really as two monoliths. They're not microservices and they don't share any components. One of the big problems with what happened is that the lunar module wasn't designed to hold people for as many people as it needed to hold, all three of the crew, as long as they were going to have to hold them there because their monolith number 2, the command module, had blown up and lost a whole bunch of oxygen. There's this famous scene in the movie where they realize that they just need to get filters from the command module to work in the lunar module. And of course, those filters work in totally different ways. Again, this is a monolithic approach, right? So each monolith has duplicative services rather than the components they need. So there's this famous scene in the movie where they say, we need to make this fit into this using only this stuff that we can find on the spaceship. And I like this example of microservices because it just shows that being able to reuse the components, being able to have a single service that you can scale up independently. Like if Oxygen is just its own service, then we can scale that independently rather than if it breaks in one monolith, now you're in trouble because you can't get the services into another one. At least that's the way I would think about it from a space program standpoint. And of course, the scalability aspect is a critical one. So, all right, I'll put away my space helmet. Again, it's just the briefest sort of a fun introduction to microservices if you're not familiar with it. But basically, they allow us to run services independently, and they also allow us to scale them independently. So we could scale up the services that we need. And it also solves a lot of problems around the development workflow that we'll actually get into with the CI/CD components here. So first, Expedia a few years ago had acquired several companies, Egencia, Travelforce, and they had essentially 3 monoliths for how car rentals worked. And so each monolith behaved in its own unique and different ways. And they wanted to, of course, not only merge the databases, but they also wanted these services really to be part of one service. So they started the switch to multiple services, microservices really, using a single UI UX. And so they created a service just for car search, a service just for car sorting, a service just for bookings, a service, and then of course the unified UI, and then the different phone apps, different clients and aspects like that. Whereas all of these components basically had to previously exist within each monolith. And of course, that meant a lot of duplicated effort, as well as like one component could break in Egencia's stack, and now you have to go figure out how that stack works specifically, rather than just saying, hey, we just know how car search works, right? And we're just going to make sure that that works for everybody. So the first thing they did, obviously, was to consolidate their code bases. They started building out shared libraries that they could pull and use in each service as needed, which worked okay. They did rely a lot on manual integration testing to make sure that this stuff was working. And they tried to standardize their CI/CD pipelines, but this was actually a really difficult process because they actually had so many microservices they had to work with. Now, a big problem was obviously they had a geographically distributed team. Well, the consolidation was really difficult, but the biggest thing with the pipeline standpoint was that their previous approach was, I'm going to have one service, I'm going to have one repo for that service, and I'm going to have one pipeline for that repo. And all of a sudden, now instead of having maybe 100 pipelines, they had thousands of pipelines. And that meant that every time they wanted to tweak something, they now had to either mess with like a global library that could potentially break a lot of people's configurations that were unique, or they had to go through and just change each pipeline either programmatically or manually. It's a very, very difficult challenge. And of course, the pipelines were not really modular or reusable, even though they did have modular components. And then they just had a lot of issues with Jenkins, and of course, people did a lot of copy and paste between pipelines. So this made the whole flow really difficult. And a big aspect of this is the way that plugins and shared libraries work within Jenkins or classic CI/CD services. And we'll get into that in a second. So they learned that the business needs kind of stuff that they had was obviously very important, but they didn't have a plan for how they were going to scale their CI/CD and their automation that was actually realistic. And so without that, it was going to be very difficult for them to be successful with this transition. And this is really the key aspect. If you're going to, everybody knows, as you scale, you feel pain points in different locations, right? First, you're like, oh, I just need a way to replicate the service. And then I need a way to get enough CPU time. And then I need a way to get the network to work. And then I need a way to get the storage network to work and not get the storage speed to go fast enough so that I can move this. As you scale, you hit into different roadblocks. The biggest issue with moving to microservices is actually just the scale of your automation and how it's going to work. And so it's actually in the CI/CD area that we find that most people have the biggest bottlenecks. And that, of course, reflects back onto organization and how the team works and all those kinds of things. So having a scalable approach is really tricky. And I mentioned that this single pipeline per project was a big component of this. This is kind of a classic way that people think of how to do CI/CD. Hey, I have a Git repo, I have a pipeline for that repo, always. Well, when you have thousands of microservices, thousands of repos, this starts to get really, really hairy. And they can also be complex and difficult to maintain. And in the case of Expedia, they were all centrally managed. And that meant that they had to have a team that could go and interface with these thousands of different microservices and understand all their specific needs. And this made it really hairy. And then you have people starting to spin up their own CI/CD services because they don't want to use the one that's not fit for them. And it's a mess. So this issue where they would take a monolithic application, and you might have 3 pipelines associated with a monolithic application, maybe something for working with dev. Sometimes you do one big kind of monster pipeline, and sometimes you do like, oh, this is the dev pipeline, this is the production pipeline, this is the staging pipeline. Well, yeah, that's basically what they had. They had 3 pipelines per repo. So when they started splitting those up into 4 different microservices per monolith, all of a sudden, this massive explosion of the number of pipelines they have. There's so many things going on that it just gets very difficult to track what's actually happening. Now, the big thought in the beginning was that they would use shared libraries as a solution. Say, okay, we're going to create these shared pipeline segments that everybody can use. Well, this is an architectural problem with traditional CI/CD solutions that most of them are VM-based. Even something like Jenkins on top of Kubernetes is essentially taking a sort of VM-based attitude into those pipelines, where I execute a job within a specific pod that has specific attributes. And the problem with these shared libraries is that they are version specific and they create conflicts. So this doesn't work. It requires everybody to use the same version of a library. That's a big problem, because let's say that I'm using, Java 2.3 and someone else is using Java 2.1. Well, now I have a conflict. I have to be on the same version when I'm using a shared library. I can't. Using multiple libraries is really difficult. You can't do that. So what you end up doing is you end up creating and spinning up new instances of your CI/CD. So this is a problem. It's also difficult because libraries rely on each other in complex ways. And so anybody who's gone through the process of trying to upgrade these libraries finds that they run into extremely hairy problems, and they're hard to figure out because you have to test it for all the different scenarios of your users who are doing their own flavors and cocktails of different versions, different languages, et cetera, even sometimes different architectures. If you're talking about like people that are building on ARM versus like x86, and you got somebody doing a Windows service, that gets really, really hairy. And people used to maintain these huge libraries of VMs to do this stuff, and it's really challenging. And of course, changes have to go through the admins, which is a problem. There's lots of stability problems because of this shared library approach, and of course, it does rely on a proprietary API. So that's kind of the problem set. And so I'm going to share how we do this internally at Codefresh, how we do CI/CD for microservices. And again, there are a lot of lessons in here that we've also learned from our customers specifically, as well as the community. And so there's a lot of principles in here that should be really helpful. And we found these successful. Just to introduce how Codefresh works, this is what our architecture looks like. We have a complex microservice stack. We are both Git and cloud agnostic. And so that means that we have to have first-class integrations for all these different Git providers you see on the left. And we also have to have first-class integrations for all these cloud providers on the right. And so that leads to a fairly wide surface of features and usability that we have to make sure works. At the same time, we have this whole microservice stack for managing the application, in addition to these environments that live on external Kubernetes clusters that are actually running pipelines and executing jobs and things like that, in addition to a Helm chart registry and a few other components. So you can get the sense that this is a complex stack to manage, and each of these components has There's a mix of languages going on here. We have some Go. We have a lot of Node.js going on. Those are the two biggest languages. We have a few other services in there, obviously our database services and things like that. So this is complex. So the first principle that I want to impress is that you should use a container-based pipeline. Now, a container-based pipeline means that you build a task into a Docker image. And at first glance, you might think, okay, well, if I have a container that knows how to run a test, how is that really different than a shared library that knows how to do a test? I mean, you just told me, Dan, that shared libraries were terrible and caused conflicts. Seems like a Docker image is kind of the same thing. Well, there's some very, very big key differences. One, users can self-serve whatever image that they want with whatever version they want. So you're not dictating what they have to use. Also, images do not rely on each other in any way, right? An image is independent. So I can run Java 2.4 in an image, and the next step I can run Java 2.1. And there will be no conflict whatsoever because they're running in their own containers. And I actually saw a post on Reddit, I think it was even just this morning, that was somebody talking about how to run Jenkins on top of Kubernetes. And they were explaining how for every task, they take the Jenkins agent base image and build additional Docker images based on that image with the additional tooling they need. And I just thought, this is like such a crazy bonkers way to do this. Go on Docker Hub. There's already a bunch of images for all the versions of Java and all the versions of Go and all the versions of whatever language, and as well as images that are specifically for running tests and things like that. There's just these massive amounts of resources out there. So the idea that you're gonna have to rebuild every container yourself, I think it's a big miss, and it's just a lot of wasted effort. And again, the flexibility of using a container-based pipeline means that you can support any language. So this whole conversation about like, you have this sometimes, especially with when another team is managing your CI/CD pipeline and they're using a traditional CI provider, you'll say, hey, I need this version, and they don't offer it, right? So you have to rely on them to go and provide that. And they're like, oh, well, we don't support that. And it's like, well, this is crazy. Like I have a Docker image that has that language on it. So let me just run that thing. And somebody just mentioned in the chat, like maybe just some examples of what these steps name are in case it's unclear. So a step might be building a Docker image. A step might be git clone. Just go and get the code, right? A step might be run unit tests. A step might be lint my project. A step might be run a security scan. There are hundreds of these. I'll actually look at a couple of examples here in a second. We have a huge library of steps available if you ever want any of these. And they're not exclusive necessarily to Codefresh. They're basically just Docker images with schema associated with them. But you can see, and they're versioned independently by any user that grabs them. So you can do Canary releases, blue-green deployments. There are steps for that. There's Kubernetes deployment steps. There's Helm deployment steps. There's Terraform steps. Just a huge variety of steps. Some of these are maintained by Codefresh. Some of these are maintained by the community. And again, this is a huge open source library that anybody can grab and use. So that's a good resource. Another aspect is that we, instead of going with this one pipeline, one repo, one application mentality, we suggest using a single pipeline that operates with multiple contexts. So we actually have a lot of customers who will, when they start, they'll have 300 pipelines, and they will trim that down to like 10 pipelines, where basically they have pipelines that are somewhat generic, but they operate within a context that can do different things. So I'll show you what that means. It does encourage people to make microservices a little bit more uniform, but it doesn't mean that they have to necessarily match on languages or even on like testing strategies. They can actually have some diversity in there, and the pipeline can actually withstand that diverse use case. And so it's going to change based on context. So the way this works is that to provide context, you have triggers. Now, a trigger would be like a git commit, or so like a git commit to this repo on this branch, that's a trigger. A git commit to this other repo, this other branch, that's another trigger. Someone pushing a new Docker image, that could be a trigger. A new version of something coming out, that could be a trigger. So a trigger could also be time-based, right? So you can have all these different kinds of triggers, but then the behavior of the pipeline actually changes. So when a trigger, such as a git trigger, comes in and it says, hey, there's been a change to this repo, the code base is going to bring all this metadata with it, with that trigger. So it's going to say, okay, my pipeline, for example, usually almost always the first step in a pipeline is to do a git clone. Okay, so the trigger says, this is the repo you're going to clone. All right, this is the one that changed. So this is the one you're going to work on. So it's going to clone that repo and it's going to pull into it its whole code base. It could have tests that are in there. It can have dependencies. It can have a Helm chart. It could have even Docker Compose for running different kinds of tests and things like that. And then you just have steps that consume those different pieces of metadata. And I'll actually show you this in action. I have a demo of this in a bit, as in right now. So let me switch my screen share here. And we'll jump, excuse me, we'll jump into this. So here is inside of Codefresh, a pipeline that we call CI. And I'll pull this up in a second, but I just wanted to show you what it does. The first thing it does is it clones the Git repo, right? And then it does a few different things to extract different variables from that repo, validate the versioning. And actually this one, the way this works is after it validates everything, it actually creates a pull request. So this is actually handling different aspects. Now, that's actually a little bit too into the Git flow. I don't want to spend much time there. It does some linting. It runs unit tests. It actually spins up a composition. Depending on the variables, it will actually spin up a set of services and run tests against them. And then it will build a production image, push that image up to a repo that, and then push up a Helm chart as well. So this pipeline is actually covering a ton of different services. So if I click on this pipeline here, it will actually show me all of the different triggers associated with it. So you can see we actually have dozens of triggers associated with this single pipeline definition. So each of these triggers basically carries with it its own set of criteria. And if I look at the builds, you can see all of the different services have been executing and building within this pipeline. And one of the big things about this is being able to filter it down, because once you have hundreds or potentially thousands of microservices, having views that are going to allow you to filter down to what you want to see is really critical here. So here you can see that our last build was 31 minutes ago. Looks like everything went properly with that one. We had one that failed back here. We could go dig into that. And I can see the commits and I can see who's actually making the changes. So if I needed to track them down and figure out what's going on, I could do that. But I could also say I only wanted to look at stuff for the CF API. I can actually just put a filter up just for that and then see only those commits. And if I clicked on the origin branch, I'd actually be able to see exactly what code change was going on. So I could actually jump straight into that. I don't want to dig too much into the code for that application. I'm actually not familiar with it myself. And you can also save these views, and so you can create default sets that you look at. Now, we actually also do the same thing for CD. We actually have a pipeline that's just for continuous delivery, and you can see what happens. Now, this is just an example of our Git flow, and this one's I'll share how we're doing it. However, I wouldn't necessarily say, hey, this is the best practice for how you should do this. I think this works very well. Now, we use Helm for all of our deployments. So what we do is in that CI process, once everything has been tested and working correctly, we actually create a pull request to our to a centralized repository that keeps all of the Helm charts. And then that has creating that pull request actually triggers the tests for these different pull requests, and it'll actually spin up the Helm chart and test it. So You can see all the different triggers that I had there for all of the different sections of the repo. Well, actually, let's go back to that for just a second. So if I pull open this trigger, for example, you'll see that this one is taking only new branches over here and testing those. And then it's also checking only for if this file was modified in this commit. So you can see you actually can do pretty granular trigger filters on these things, as well as definitely looking at pull requests and things like that. So let me show you a build, and you can just see what this looks like. Now, all of these, as I mentioned, I believe I mentioned, are defined by YAML tests. Now, we have some that looks like Raziel was making some commits, and he caught some errors, which is great. This is exactly what you want from your pipeline is for it to catch errors. Now, in this case, it's actually referencing an externally defined pipeline. This is a run E2E pipeline. If we look at the YAML, you can actually see that this is running a specific pipeline that runs end-to-end tests. So we actually have a pipeline that is templatized that will then call an external pipeline to go and run a test. So you can see how there's a lot of modularity here, right? Each step is a container that's modularized. And each pipeline is also essentially like a module, so we can call a pipeline from another pipeline. And this allows us to abstract a lot of complexity and make the whole entire CI/CD process much, much simpler and easier to deal with. Let's see, I think we're doing okay on time, but I want to jump back into some other principles here. And if there are any questions on how we do this CI and CD from a scalable standpoint, feel free to throw them in the chat or in the QA, and we'll come back to them. All right, I'm going to switch my screen back. Okay. Now, another aspect here is, get my slides. There we go. Another aspect of working with microservices is that the deeper you get into microservices, the more useful advanced deployment methods become. So this chart here actually shows the complexity of the infrastructure increasing, and the usefulness of early testing decreases as you go along. Now, why is that? Okay, well, if I have a simple monolithic application and I run a CI pipeline, it's going to run unit tests, right? Those unit tests are going to cover basically all the libraries that are within my monolithic application, right? Now, if I then split that up into microservices, well, the unit tests are going to still cover each service's libraries, but they won't cover their interaction. Now I need an integration test to show that those two components still work together. Even though it's the same libraries, I've now just split them into two different microservices. And when you have two microservices, this is still pretty much like doing the integration testing, not that difficult. Well, when you have 150 microservices, when you have 500 microservices, when you have 1,000 microservices, all of a sudden spinning up all of those microservices to run tests starts to get cost prohibitive just from a compute standpoint, because I have to run all these different components together. I now have, like, in the network overhead, all these different elements. So the unit tests cover very, very little now, and the integration tests cover more and more and more. And at a certain point, just spinning up all of the infrastructure to cover all the integration tests starts to become prohibitive. So one strategy that we really advocate is doing canary releases. And canary releases are basically this idea where you release, a new release actually just gets only a portion of your users get exposed to this new release. And if there are any issues, it'll be caught and rolled back automatically. So that allows you to have sort of a catch-all way of releasing software that will automatically pull back if there's a negative impact on users, and you really limit the blast radius of a change that goes wrong. So if you just did a push to change and you exposed it to all your users and there's something wrong, all your users have a problem. But if you push a change with a canary release, 5% of your users have a problem that's automatically remediated, and then they can go about their business. It's a much, much better way to release your software. And this becomes more and more important as you increase the complexity of your infrastructure. We have a whole webinar just on that topic that I think Taryn put into the chat, so feel free to go check that out. Highly recommend it. The speaker who gave that one is highly dynamic, as dynamic as I am, so it should be at least entertaining. By that I mean it's me. Oh yeah, good questions coming in, so we're gonna get into these. In summary though, shared pipelines, much better than shared libraries. Shared libraries, can't say enough bad things about them. It's just, I think it's a really bad way to build CI/CD pipelines. But shared pipelines, those are awesome. They work really, really well. Reusable Docker images work way better than a lot of copy pasta scripts that are just jammed into pipelines. And of course, validating your deployments with Canary is highly valuable. Now, there actually is a blog post all about this that goes that if something was unclear that I was presenting, feel free to go read the blog post, should be helpful. And with that, I think we can get into questions. Now, if you do decide that modern CI/CD is critical, feel free to check us out at codefresh.io. You can create a free account and try all this stuff out. Again, I am at Today Was Awesome on Twitter, and I had help from Mr. Kostas Kapolonis at CodePipes on Twitter. So feel free to hit him up as well. And we do have a little special offer. It looks like it just came up to schedule a one-on-one demo if you want to see how to use Codefresh specifically for your team. So with that, I want to answer some of these chat questions, and then I think a moderator will come back on and want to take us through some Q&A. Somebody asked, Paris asked, can I use your pipeline with one already built in other tools like Jenkins, Puppet, Chef, Ansible, etc.? So yes and no. We actually do have a lot of, so Codefresh is really around application management. So I would say that Ansible is serving like a different job, same thing with Chef. So we actually do have a lot of customers that use Codefresh to execute Ansible or Chef components when it comes for their infrastructure management, just in the same way that they would use Codefresh to execute Terraform, right? We do have a Jenkins plugin. Sometimes that's used to pass information between Jenkins instances and Codefresh, but it's usually tends to be that people choose to use Codefresh or choose to use Jenkins. And Jenkins sort of has a sort of limited future. You know, it's been around for a long time. It's done a great job, but we're talking kind of about the next generation where we're going to go, and that's where I think Codefresh fits in. Someone also asked if we were using Tekton behind the scenes. And we're not using Tekton underneath Codefresh. Codefresh predates Tekton, and we have a lot of sort of technology that is advanced from where Tekton is today. We are very much interested in potentially coming in and contributing to that project, and then maybe adopting Tekton ourselves, just so that we have a standardized kind of open source approach. But that's not something that's happened quite yet. So that's something that we're very much investigating all the time. So that was a good question as well. Tejas asks, how about running functional testing in CI? Yeah, and I assume you mean here by like UI. So for example, there are two different things I'd say. One, running like Selenium inside of CI, your CI pipeline, very reasonable. Now, because Codefresh has things like deployment steps, taking a Helm chart, spinning it up into a one-off environment, and then running your functional tests against that, very reasonable. Now, a lot of people, what they actually do, if they have manual testing that they want to do, it's functional, they'll actually have a step. And there's a bunch of guides on how to do this, but they'll actually have a step that will spin up the infrastructure, and then they will put a link to that infrastructure back onto the commit or the pull request, so that somebody can actually just, boom, click right there, jump straight into the environment, see what they need to be able to see, and then maybe do an approval or whatever, because you can have approval steps as well as just using approvals within Git flow. So that's a good question from Tejas. Paris asks, do you work with other deployment practice other than or in coordination with Canary? So Canary is probably actually not as popular as Blue-Green. Blue-Green is something else we support. But I tend to not see too many other than standard deployment, you know, Kubernetes rollout, Blue-Green and Canary. Everything else tends to be just kind of a variation on those things. So that's a good question. I'm going to flip over to the QA slide. Pramila.
Dan.
Oh, yeah.
I'm sorry. Absolutely, Dan. Why don't you just continue on? Keep rolling. I know that there's a poll that just popped up for the attendees as well to answer quickly if they could.
Cool. Pramila asks, hi. I got a second poll. I'm going to tell myself that it was awesome. All right.
I think it was.
Pramila asks, hi, San Francisco. I want to know, does this meeting... Oh, I'm not sure I understand that question. I'm going to move on. Levin asks, how long does a typical pipeline take to complete? Oh, okay. This is actually a really interesting question. So I'm aware of organizations that have pipelines that take 25 hours to run. That is a very extreme case. It's very unusual. Typically, pipelines should be in the order of minutes. Now, in this particular presentation, we didn't get into optimizing build speeds. We do have a really cool presentation on that I'm sure Taryn will throw into the chat. We actually had a customer who gave a talk at KubeCon, and they said that they had a pipeline that took 120 minutes, and they switched to Codefresh, and it went to less than 12 minutes, I believe. So typically, you want those things to be in the order of minutes, not in hours. And that's because you want to be able to give the feedback to the engineer if what they are doing is working right away, because while they're still in the headspace of working on that application, they can make fixes, and those fixes are way less expensive than they otherwise would be. So good question. Sean asks, how soon will this recording be available? I work at Adobe. I'd like to send this webinar to my team's automation lead. We're using Jenkins currently, so maybe there's something for us there. I think you also got an invitation to set up a one-on-one, so I'd highly encourage that, Sean. But I believe that they said within 24 hours, it should be up.
24 to 48 hours, it'll be up. Yep.
Cool. So it should be quick. Bill asks, has Expedia fixed the problems you laid out, and are they a client of yours? So this is interesting. This presentation, I originally put it together with an engineer that worked on this project at Expedia. So they worked on that project. And then they came and changed companies and then shared with me exactly what was going on. So Expedia is not a current customer or anything, but this is basically like, hey, let me tell you what we learned, and then I think if we had something like this, it would have been so much better. I do have similar kinds of case studies though for a lot of different companies. So if you go to codefresh.io/case studies, you'll see like Bosch is in there. You'll see a lot of really great case studies that we've done. And we have customers like Gap, Epic Games, CBS, AT&T, Time Warner, basically all the streaming that AT&T does. So if you ever watch CNN.com or adultswim.com, it's all software that's built and deployed using Codefresh. TJ asks, does this pipeline also include application security testing? Yes, it does. We actually do security testing generally at a few different levels. There are a lot of different scanning tools out there, and there are a lot in our library. So ClairScan is a free one that's very good. ClairScan, I believe, is actually maintained. Who maintains it? Aqua actually has also another open source one that they offer as well that does container scanning for free. So you probably actually want to have several different layers of security scanning, because there are a lot of different security scanners out there. Some of them check just the libraries within your languages. Some of them check the images that you're using. Some of them you can actually just do fuzz testing, which is very time consuming, but you might want to separate it out from your process, for example, if you're going to do that. A good question from TJ. Paris asks, integration, performance, and load testing are something we could do with Codefresh so that we can conserve cluster resources during staging. Yeah, so we didn't get deep into this, but one of the things you can do inside of a Codefresh pipeline is you can actually have a step that spins up several different services so you can run integration testing right within a pipeline. Now, I wouldn't say that this is a full replacement from doing something like a staging environment or even like a canary release. However, especially for a ton of services, it covers like 95% of the potential issues that you would have. So it's a really, really great method and it can run really, really fast. So I highly recommend that. Tejas asks, additionally, dependent components in test phase, such as running Kafka and such test database, this adds a lot of overhead to the CI/CD pipeline. Yeah, that's true. It would. I want to, we probably don't have time for it. You know what we should do? We have a link to debugging with breakpoints that actually talks about it. It's not about using services within a pipeline, but it actually has like a really good example of using services in a pipeline. So Taryn, if you wouldn't mind throwing that into the chat, I think that that would show it. But you can actually, it actually is a lot. Yeah, it is overhead in your CI/CD pipeline for sure, and you can use conditionals in your pipeline for when those things are necessary. Or you can even separate them out if things are taking too long for the developer to get feedback, but they're things you want to track over time. You can actually make them non-dependent pipelines, so you can actually run them independent of your flow, so you can at least track it and see if there's some things you can do. Okay, great. Geraldo asks, how are the steps run? Synchronously, asynchronously, doesn't matter. Your choice, right? So there are a lot of steps that you can do in parallel, right? Because they're not dependent on one another. And this is one of the things that people often, it's super critical when you're going through and optimizing the speed of your pipelines. And I'm going to reference another webinar that I think I referenced earlier. We did a whole presentation about how to speed up builds, and that's pretty cool. But running steps in parallel is a huge time saver, right? And then you can also do dependency steps. So you can just say, hey, this step can run as soon as this other step is done. So you can either lay it out linearly, or you can do it with a dependency map. And do it that way. Okay. Paris asks, does it support log? I guess you're asking about Codefresh specifically. Does Codefresh support log monitoring and other information that other tools such as Prometheus and Grafana? Yes. So you can gather those. So I think you're probably thinking about within the context of a canary release. This is something you can do. You can actually set up a step that checks the logs from a Prometheus or whatever logging provider you have, and then looks for issues and then actually tags markers. You can also send, I set up a step a while ago that would send logs from a Codefresh pipeline into a third-party logging provider. And that's something that we're going to get better support for here. So you don't do it with the step, but it's more first-class support that we don't quite have yet. Stark asks, is there a way to implement this same sort of system using G-Cloud services? Yes. So you can actually run Codefresh on top of G-Cloud, for one thing. Or maybe that's not what you're asking. Actually, Stark, if you wouldn't mind clarifying your question, I would be interested in, maybe I'm not answering the question that you're thinking of. Dan, your Twitter handle's missing an E. Oh no, today was awesome. Man, that was great. We got through a lot of questions. I don't know if Stark is going to add more clarification. I think what you're asking is just like integrations with G-Cloud. We do have a step for that, and actually Google provides an image with G-Cloud tools on it, so you can actually drop that directly into a pipeline. It wouldn't have to be Codefresh; it could be other components. Yeah, if I can't convince the management to use Codefresh, yeah, totally. So the principles laid out in here still apply. So running a container-based pipeline, you can do container-based pipelines in other platforms. There are potentially some sticking points for how those are going to operate, just in terms of like how they deal with caching and how volumes work and those kinds of things. You can do container-based pipelines in other platforms. A lot of people do container-based pipelines in Jenkins. It's certainly a lot more work because it's not designed kind of from the ground up with that in mind, but it is definitely possible. Paris asks, are you partners with Azure, GCP, AWS, IBM Cloud, and others? Yes, 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 and yes. I mentioned earlier that we are cloud agnostic. And this is actually a key function for Codefresh, is that we can be, what we find a lot of, just kind of sharing our approach to things, what we find a lot of is that there are a lot of code providers who have started building CI services on top, right? You've got GitHub has done this, Bitbucket's done this. You have cloud providers that have started to build some pipeline components. AWS has one, Google has one, these other ones have one. What we find though is that most organizations have difficulty standardizing on these things. And when your CI services are provided by your Git provider or your cloud provider, it's really a tool for vendor lock-in. So what we want to do is we show up and we're say, hey, we're Git agnostic, we're cloud agnostic, we're going to work with whatever you're using. Go ahead and plug in your components and you're off to the races. If another team is using a different cloud provider, that's great. We work with that cloud provider really well too. So we kind of want to be the Switzerland of DevOps tools, if you will, because we feel like that allows people to just adopt the tools and just move forward and get on with building their software, which is after all, the whole point of all this stuff is so you can focus on your engineering. Someone else, Stark, you also mentioned the difficulty of convincing management. I'm going to make a plug for another webinar, which is all about the business case, making the business case for DevOps. And we have a whole blog post with calculators where you can actually show like, hey, here's the cost difference of doing this versus that. It's, again, not necessarily totally unique to Codefresh, but is meant to be more general about DevOps in general. But it does give you maybe some tools that you could use to help convince people. Paris asks, what security and compliance can be addressed with Codefresh.io? Yeah, actually, there's a couple things. And I'm obviously happy to answer questions specific to Codefresh. So Codefresh does have auditing built in, so you can see every action that's taking. That's just going to help with your PCI compliance. And then we also have support for hybrid infrastructure. So one of the issues that, like I'll use Gap as an example. Gap, Old Navy, they're one of our customers, and of course they have a lot of strict requirements around data and code and how that's shared and things like that. So what they do is they use what's called the Codefresh runner, and this is basically an element that runs on Gap's Kubernetes clusters that runs all of their builds, and that means that all of the code, all the secrets, all the data stays on their own infrastructure, but it's actually managed from Codefresh.io as if it were a SaaS. So it doesn't have the same management overhead that people are used to with something like a Jenkins or something like that. So this actually allows them to meet all of their compliance and security requirements and keep all their code on-prem while also having like a cloud-native next-gen CI/CD tool. And then, of course, another big thing is just a visibility perspective. So one of the things that, I'll give you an example. We didn't get into this aspect of it, but if you wanted to know what's currently running in production, what most people will do is they'll look at the pipelines that they've run and they will say, oh, this is the pipeline that I ran last. That's probably what's running in production. Codefresh actually will show you exactly what is actually running right now in production. And if you click on it, it'll actually take you straight into the code commit so you can view that stuff. So that's the kind of stuff that brings a lot of visibility and actually helps with some of the security compliance aspects that people are talking about. In addition to just setting like gates, security gates around like, hey, scanning has to be done in order to move forward. One of the things that I'd like to do a presentation on soon is the idea of black box pipelines. So we touched on it briefly that you can use a pipeline to call another pipeline. You can actually have a security team create a security pipeline that says all of these things need to be met in order for a deployment to move forward. And users can call that pipeline, but they may or may not necessarily be able to see what goes on inside of it. So they may be able to just get back the issues of, hey, you need to fix this thing. So that the ability to make that visible or invisible is actually really interesting for security teams because sometimes they don't want to necessarily show the entire surface that they're looking for. Stark asks, I currently use cloud build triggers to do container-based pipelines, but they don't seem to share the flexibility and metadata pieces you described. Yeah, this is the issue, is that a lot of pipelines weren't necessarily designed specifically with containers in mind. And so they don't necessarily show the same flexibility and metadata. And that I touched on earlier in an answer to a question, the issue of volumes and how those are handled. This is actually super critical while we're just talking about security. Homebrew recently was hacked last year. If anybody used Homebrew, they were hacked because of an issue with how volumes were handled, because they needed to be able to share, they needed to be able to provide caching. And so the way that it worked is you could open up a pull request and you could get access to the cache in Homebrew. Now, this is a problem with how they implemented their CI. And this is, again, not a Codefresh thing. Codefresh actually has built-in rules around this and how volumes are managed, because it's all managed behind the scenes for the user. Now, you can manipulate it, but it's basically managed with really, really smart defaults and really good security. So that helps a lot. Stark asks again, oh man, that feature is exactly the one I would have wanted to develop for our services. Being able to tell exactly what is running and where, and the dependency connections is so useful. Go try out Codefresh, man. We got it over there for you. Getting some good feedback. People said this was a good presentation. I really appreciate it. Again, if you have criticism, feel free to send it my way. Anything that you'd like me to do better, very interested in that. And hopefully all of these things that we've shared are going to be useful to you, regardless of what tools you choose in the future. You know, we try to be principle-based. Now, there's definitely a lot of stuff in here that's like, and Codefresh makes this easier, but we try to be really principle-based so you can take this and apply these principles today without necessarily having to make a tool change. Awesome, and it looks like we got pretty good feedback from everybody, so really appreciate it. Again, you can find me on Twitter @todaywasawesome. And with that, I think we've covered it. So I'll pass it back to our moderators here.
Yep, great, Dan. Thank you very much for that great presentation. I just wanted to remind everybody that they can open up a free account today at codefresh.io to utilize the technology. That's number one. Number two, as we discussed just a little while ago, the webinar will be available in 24 to 48 hours, and that will be a link to that will be emailed to your email address that you use to register, and you can forward that on to your coworkers or whoever else you want to share that with. And that recording will also be housed in our archive, which is held at devnetwork.com. But I wanted to say thank you very much to Dan and his terrific snap filters as it relates to NASA. And thank you very much for everybody for joining, and have a great day and a safe day.